I'm James Leake. I'm a lecturer here in civil engineering here at Edinburgh Napier University, and I teach a range of subjects including land surveying, project management and geotechnical engineering. But I'm here today to talk to you about the surveying equipment that we have for students at Edinburgh Napier University. So what we have here is two Leica levels, which are commonly used by the first year civil engineering students here in the civil engineering course at Edinburgh Napier University. We have here an automatic level, which is frequently used in industry and by our students. And we have here a more advanced self level, which is more used for sort of masters and honours project students. So what we have here with the automatic level is a scope in which a surveyor will look through, and the surveyor will be looking for another surveyor holding this staff in which they will read off the rule and then log the measurements in the logbook. The self level is, as I say, a more advanced version of what we have here, where instead of having to read the measurements and log them into a logbook manually, we have a barcode reader in which the measurements are logged inside the machine, which makes things a lot easier and much quicker as well. What we have here are the different types of total stations that we have here at Edinburgh Napier University. We have both Leica equipment and Trimble. We think the range of different equipment types gives students the advantage of being familiar with the different types of equipment that they may experience in industry. A total station is kind of a jack of all trades. It uses an electronic distance meter to electronically scan and log surveying points into the machine, which makes things much easier and much quicker. It essentially measures both horizontal and vertical angles and distances, and automatically it can be quite easy to calculate different areas and volumes as well for like setting out engineering. So the total stations, similarly to our levelling equipment, are predominantly used by our first year civil engineering students. They undertake both practical coursework and practical exams in total stations and setting out. Essentially, they work by having two surveyors, one here above a known point, who will look through the scope to another surveyor who holds this staff, and the laser reflects back off this staff back to the total station, logging the height of the datum.
I'm Andrew Livingston. I'm a lecturer at the Built Environment at Edinburgh Napier University. I teach on various modules, but one of which is a surveying module. It's a third year module, and it's called Digital Design. You saw the total stations before. Well, this is also a total station, but it's a robotic total station, and it's also a lot faster than the previous system. If I've got my reflector and it's mounted on a pole, and I also have my tablet on the same pole, I can walk around the site and then locking in each of my locations as need be onto my geospatial tablet, walking around. So it's a much faster and more eloquent system, and the more sort of thing that's used in industry today. This is a Trimble three-dimensional scanner, or a TX8. This can be used by almost any built environment specialist. So architectural technicians who want a full scan of an asset would pick one of these up, easily set it up, and it's really simple to use, gather the data, and then take that data back without the need of any specialist surveyors. Or surveyors could also use this to scan assets that are hard to reach locations. Industry is really taking on board the benefits of using such equipment. So students have their hands on using the real equipment that they would use in industry currently in the market. So this is the XR10 or HoloLens 2. It's essentially a Microsoft HoloLens bolted onto a hard helmet with a computer in the back. In addition to that, it's also got LiDAR or 3D scanning technology from Trimble bolted into it. It's useful for what's called augmented reality, so scanning the existing where you are, showing you visually where you are, and then interlaying that with perhaps a three-dimensional model, or what we would call a BIM model. When you're wearing the helmet, you don't have a physical keyboard. What you have is hand gestures. So you can literally start up the menu by closing your fist and touching your wrist. The menu comes up, and you then start controlling by pointing or clasping things and pulling things or pulling things apart. You can also turn layers on and off. Layers could be things like your furniture, your electrics, or your windows, or your fittings. So who would use this equipment? Well, architectural technologists would use this more extensively, for example, but engineers would also get introduced to this in first year. Then in third year, there's a module, digital design, where they'll be using multiple softwares and hardwares, doing design into three-dimensional modelling. They bring that three-dimensional modelling into a digital environment and then viewing that within the helmet.